Okay. Okay, so this says the terminal side of an angle has this XY point. What is the tangent of that angle? Now, here's what honor students tend to do. Way overthink these. Remember, these are brushing the surface type problems. So don't start overthinking it. Terminal side just means we have an angle. Terminal means we have some angle created, correct? Some angle created. What do you notice about this XY point here? It's on the unit circle. Did it ask you what? So somebody kept saying last hour, can I use the unit circle? You don't need it. It did not say what angle is this or anything, did it? Don't we know it's definitely in this quadrant? Well, that doesn't even matter. It says, what's the tangent of that angle? If that's on the unit circle, how do we find tangent? Yep, sine over cosine or y over x. So we would literally go, oh, okay, I'm doing root 3 over 2 divided by negative 1/2. Dividing fractions is easy as pi, flip the second and multiply. So we times by negative 2 over 1. So then those would divide out. So then wouldn't it be negative root 3? It'll be a computer-based thing, so you would then type that in. If you should not miss that problem. But some people start to try to overthink it. It must mean something deeper and darker. No, it doesn't. All good? Next one. If you need to take a picture, do it and write it down later. Okay, so this one would be open-ended. There will not be very many multiple choice. It's like barely ever. There's not multiple choice. So this one says, create a cubic equation with imaginary roots. Create a cubic equation with imaginary roots. So with it asking us this, they will have in their computer system an algorithm that accepts many correct answers because it's leaving it very open-ended. However, it has to fit all the criteria. So it says it's write a cubic equation. So what degree is that? So in the end, it needs to be x to the third, correct? Now it says with imaginary roots, if you just try to go like this, x cubed plus 2x minus 3, you get what I'm saying? Like you're not going to know for sure if you've done it right. If you try to do it that way, it's going to be way hard. Instead, work backwards. If it has degree 3, how many solutions does it have? So we have an x equals something, an x equals something, and x equals something. Now it says it needs to have imaginary roots. Aren't roots solutions? So any imaginary solutions will work. Now, what do we know about imaginary solutions? They have their buddy with them. A conjugate has to also be a solution. So I could choose I, couldn't I? I could choose 2i. It doesn't matter. So I'm going to go with the simplest one possible, I. So what else has to be a solution? Yep, negative I. Now guess what a lot of students do? They say, oh, it needs imaginary roots, so 2i. That will not work because if 2i is a solution, negative 2i is a solution, correct? So this, you would use any other solution, like a whole number, like a 1, a 0. Do you get what I'm saying? No, it couldn't be, right? It couldn't be. Yes, if it was degree 3. If it was to the 4th, then yeah, yes. But the reason they're doing this, so they wouldn't probably ask that, is because they want to see that you know this and that, yeah, no question. Okay, so I'm just going to use 0 because that's easy. You could use 1, couldn't you? You could use 7. It doesn't matter. Okay, so now we would work backwards. So we'd subtract I. So we have x minus I. We'd add I. So we also have an x plus I. And then we have subtract x minus 0. Do I need to write minus 0? We just have an x here. And you wouldn't want to put it in standard form. When multiplying three things together, you multiply 2 together and then multiply in the third. You should always multiply the conjugates together. So we have x squared plus ix minus ix minus I squared, and that's all times by x. So don't we have x squared, middle terms cancel out, then isn't I squared negative 1? So we have x squared minus negative 1 here. So isn't that x squared plus 1? Which makes sense. If you were to solve that, you would get plus and minus I. Then you have times by x. You would then take x, multiply it in. X cubed plus x. So then it says write a polynomial with imaginary solutions that's cubic. So you would write y equals this. That would be one acceptable answer. So if you would have wrote x equals 1, you would have had an x minus 1 here. You would have had an x minus 1. You would have had to distribute that, and that would have worked. Their algorithm would know that that has two imaginary solutions, one row. You see? Okay, cool. Last one for today, last review problem for today. Okay, it says, given this polynomial, negative x to the fourth plus 10x minus 3, tell me, as x is approaching infinity, what is f of x approaching? As x is approaching negative infinity, what's f of x approaching? So this is literally the first lesson we learned this year. Like the actual, no, we reviewed quadratics for 2 days, but the first lesson we learned of secondary 3. So isn't f of x the same thing as y? So it's literally talking about end behavior. So if you look at this, remember, you look at the leading term, you look at the degree. The degree is even. So what do we know about the end behavior? It's either up and up or down and down. And then you look at the sign in front. Isn't it negative? Don't negative people frown. So this is end behavior is down and down. It is not a quadratic. We don't care what's happening right here. We're just talking down here. So as x goes to infinity, where's f of x going? Negative infinity, right? As x goes to negative infinity, where's y going? Also negative infinity. Pretty easy. As you can see, it really is just brushing the surface of what we've gotten into. That's it for today. Now we'll start today's lesson. So you will not be using your book for this unit, but then for our last unit, we have to go back into our book for that last final unit, which will be just the last few weeks of school. This is just like a get you ready for calculus type thing. Yeah. Okay. So we're going to start out by talking about measures of central tendency. Now, just think about, literally what that means. Measures of central tendency. Stuff that's in the center of, that tend to be in the center, right? Central tendency. Stuff in the center. So that's what we're going to be talking about is the center of a data set. So it says people often refer to the mean as the average. So remember how I remember that mean means average? If I said to you, you're an average student, that's kind of mean to say, just don't say anything at all, So mean is average. But mean is only one measure of central tendency. Yeah, an average is kind of putting you in the middle, right? You're averaging something out that's somewhere in the middle. But you can describe and compare data sets using a lot of different statistical measures. It just depends on what characteristics you want to look for the study. Statistics is the study, analysis, and interpretation of data. So not only do you have to be able to find measures of central tendency, you have to then be able to know what they mean and use them to say, oh, well, so this is happening. So some more measures of central tendency, which we'll focus on today, are mean, median, and mode. So mean is average, median is middle, mode is what happens most. So let's review how to find that, which you already know how to find. So you might not even need to take notes because you already should know this stuff. So look up here. Do you see this data set? If I said to you find the mean, that would be the average, correct, everybody? So to find the average, you would add up all those data points, so adding them up, and then divide by the total number of points. So it's 4. So our average, our mean is 4. Is that directly in the middle? No, but it is around the middle. So you see how it's just measures of central tendency, right? So that's our average is 4. What was I going to say? I don't know. It doesn't matter. So then median. Median means the middle. Just think of the road. If there's medians in the middle of the road. Median literally means the middle of the data set. So you do need to make sure your data set is ordered from least to greatest, and it is, and then you'll find the literal middle. So if I go in 1, in 2, in 3, isn't the middle between those two values for this one, to get right dab in the middle. So to do that with this set, since it's split, you would add them up, divide by 2. So it's 3.5. So our middle of the data set is 3.5, right there in the middle. And then do you see how that splits it into a lower half and an upper half evenly? Okay, cool. The mode is what happens most. Most. So it's what happens most frequently, the most frequently occurring. So in this data set, do you see how 3 happens twice and 5 happens twice? So we would have 2 modes here. A 3 and 5 would be considered the modes because that happened most. Now, fun fact for you. So that'd be called bimodal because there was 2 modes, 3 and 5. If there are more than 2 modes, there is no mode because it's not affecting your data, like it's affecting your data the same. So if I added in another 9, do you see how there's 3 modes technically? That would be considered no mode. So you either have 1 mode, 2 modes, or no mode. So if I was to have in this data set, let's say I added in a 9, and then I added in a 1, do you see how 1 happened 3 times? 1 would be our mode. Still only can have 2 modes, yes. Yes, you're right. Bimodal or 1 mode or 2, there's too many modes. Okay. Now here's a new word for you, statistic. I mean, it's not that new, but statistics is a lot of just knowing vocabulary. So the word outlier. So everybody, outlier is a value that is significantly larger or smaller than the rest of the points in the data. Now think about why we want, if we were a statistician hired by Vivint or some company, because I guarantee you Vivint, that big company that has all these sales going on and all these numbers, and they're making more money than you guys can even comprehend, their company is. They have statisticians that they have hired to analyze data for them. So statisticians consider things like outliers because this skews your data. So if you have a value that is significantly higher or lower than the rest of your data set, isn't that going to now pull your center off? It's going to be kind of an untrue center. And so those are things statisticians would take into consideration. So an outlier would be something that is extremely larger or smaller than the rest of the data. So it's going to be on the low end or high end. Does that make sense? It's not going to be in the middle. So let me show you how an outlier affects it. I mean, you'll get it, I'm sure, but I want to show you an example. So this isn't exactly a true story because I've kind of changed it a little bit, but let me explain something to you. A couple of years ago, there was a teacher at this school teaching math, and we all had our end of level testing, and we all compared, you compare your scores, obviously, right? This one teacher had way, way lower scores than everybody else. They were terrible. So the next year, they were given all these math classes that were not their favorite. They were kind of like, they weren't given any special math classes. You know what I mean? They kind of took all the important ones away from them. And they said, you're going to lose your job if this next year your scores don't go up to this average. So then the year came around, and then they had to relook to see if this teacher got to keep their job. So let's look at these scores to get it in perspective. So does this teacher in particular get to keep their job? So the principal says your students have to get an 80% average score on their end of level test. We have to see your students scoring at an average of 80% to keep your job. So there were these students, 1, 2, 3, these 4 students. Does this teacher get to keep their job? Well, let's see why. So everybody, you would find the average. 75 plus 90 plus 99 plus 20 divided by 4. What is the average? So the average is 71%. So then the principal kind of wanted to get rid of this teacher anyways, right? So they come and say, sorry, you didn't reach the goal of 80%. We have that agreement in writing, so we're letting you go. So then this teacher says, well, I want to see the data points. I want to see their scores. So let's say they pull up these scores right here. Now, don't they notice 75, 90, 99? Aren't those all decently close? But this 20%, this student, is extremely lower than everybody else's. So then they get looking and they say, oh, that's Johnny. That's just the word, that's just the one I used. Not Johnny Cakes in here. This is just Johnny, not Johnny Cakes. He's Johnny Cakes. So Johnny, this teacher gets looking and says, you know what, Johnny did not even come to school literally 60% of the year. They were absent that much. Can that student really be held accountable? Can I be held accountable for that student not coming to school over 50% of the year? So they say that was an outlier. You should not have put that in because that really skews this average. My true average is what? So if I throw out that, let's add these up. What is the true average? Is it 88? 88%. So this teacher takes the principal to court, and valid argument, do you not agree? They were able to show this student did not come to school, and that really, on average, that was an outlier, that was a fluke. They never came to school. Should they keep their job? Yeah, and I can agree with them. They should keep their job. Similar stories. Like I said, I changed some things. Okay, so what I want you to do is 1 through 6. Ready, go. So, everybody, we were just talking about the center. It measures the central tendency. Now let's talk about spread, how things are spread out. That is by definition what a range is. So everybody, range is what are we ranging over? So most of you are ages 15 to 17, so there's a range of 2 years between a lot of you. You see what I'm talking about? Spread out. So to find the range, you would take the highest divided by the lowest. So if these were a bunch of cousins, ages, what do the cousins' ages range over? 12 minus 2, which is 10 years. They're ranging over at 10 years. Does everybody see? Now, we're going to talk about what's called interquartile range in just a second. Now, if we have some outliers, like let's say that I put a 20, let's say that there was a fluke, a 20-year-old, isn't that quite a bit larger than the rest of the data? So now I would change my range to be 18. But yeah, it is technically ranging over 18 years, but is that really the best range to use? I don't know. It just depends on what you're talking about. That's what's hard about statistics is there's not one right or wrong answer, but just something to keep in mind. Okay, so what we're going to do is we're going to talk about how to split this up into different quartiles. So what we're going to do is we're going to find the overall median. So if this is my data set of cousins' ages, what's the original median? So you would, that means middle, right, everybody? In 1, 2, in 1, 2. So isn't it between these two? The median. 8 plus 5 divided by 2. The median age of these cousins is 6.5. Does everybody understand what I'm doing? Okay. So now right here, it now splits this into ages down from there and ages up from there. It splits it into 2 quadrants. Well, I guess, yeah. So, I should have said, I don't know why I said quadrants, but, so now we have a lower half, and now we have an upper half of the data set. So now what we can do is let's find the median, the middle of the lower half. Wouldn't that be 3? And then let's find the median of the upper half. 10. Does everybody see? So that's what they're going to label as Q1, quartile 1. This will be considered quartile 2, and this would be considered quartile 3. So quartile 2 is the original median, quartile 1 is the median of the lower half, quartile 3 is the median of the upper half. So now to find the inner quartile range, which they'll call it IQR, instead of just range, let's find inner quartile range. How you do that is you take Q3 minus Q1. So it would be 10 minus 3, which is 7 years. So can anyone tell me why it might be better to use inner quartile range versus the original range in a sum data set? Yeah, more of the center. Like if there was an outlier, like we talked about the 20-year-old, does everybody see how inner quartile range might better describe the spread? Does that make sense, everybody? So just knowing how to do it is really what's more important. Because I'll say, find the inner quartile range. Q3 minus Q1. Okay, now we're going to learn how to put this information on a box and whisker plot. So this is what a box and whisker plot looks like. It's that same information, but in a box and whisker plot. It's the same information in a box and whisker plot. So the box part is what is created by the quartiles. So you have your box, and your first line is your median, your overall median, your quartile 2. The end of your box is the median of your lower half, quartile 1. The end of your box up here is quartile 3, the median of the upper half. Then you have your whiskers. Your whiskers just show the spread down to the minimum and the whisker up to the maximum value. So this is on a number line, notice. And I don't really care if you draw on a number line or just label it right up here, because if I did give you a number line, I'm pretty sure you would be able to do it. So watch me draw a box and whisker plot for this data set. So this is how I'm going to let it be this rough of a sketch. So this is quartile 2, correct? So we have our box, we have a line. I'm not drawing it to scale. This is our median, so 6.5. Quartile 1 was 3, quartile 2 was 10. Then we have our little whisker, and it goes down to 2. And then our whisker goes up to 12. So do you see how I didn't draw it to scale? Everybody, I don't care if you draw yours to scale, because could you if I would have given you a number line? Yes, right? You would have just put it in the right spot. Everybody good? That's how you can draw your box and whisker plot. Now, who wants to do it by hand? Not me. So let's just learn how to do it in our calculator. So watch, so I only have to show you one time, not 10 different times. I'll show you how to have your calculator just do all that information for you. So everybody, hold up your calculator. We're going to make a box and whisker plot for this data set right here I have. So you're going to pull up your calculator, and first you're going to hit second, and then y equals. So look where it says stat plot, second y equals. Now these are where we're able to turn on box and whisker plots and other things. So everybody, we're going to go to number 1, hit enter. So look, we're now in plot 1. It says off on yours. You need to scroll over to the word on and hit enter. It says, what type of plot do you want? A box and whisker plot? Do you want a bar graph? What do we want? Well, we want a box and whisker plot. Now, there's this little box and whisker plot. There's little dots here. What that box and whisker plot is doing is it's throwing out the outliers and graphing the box and whisker plot without it. You see how then it would kind of give a more accurate picture? Cool, but unless it says just graph the box and whisker plot with the outliers in it. So everybody go click right down here. Click and hit enter right there. And then it should say list 1. Does everybody see it? So now we can get out of here. So everybody hit second quit. We're doing statistics, so now hit the stat key. And we've got to go into edit. Stat, edit, stat, edit. In list 1, you're going to type in all of those values that I had listed. So it was 16, 12, 11, 15, 12. And right here, type those in into list 1. You remember how you can clear it? If you go up to list 1 like this and hit clear and then scroll down, it'll clear it out. I'm not going to do that because it'll clear out my list. Our lowest data set in here was 11, so I went to window, and in X min, I'm going to put in something below 11 so I can see below it, 10. Our highest value was a 20, so in X max I did 25. I keep my tick marks, my X scale as 1, and then Y min and max don't matter. So I just made it 0 and 1 just to zoom in a little closer. Has everybody got a decent scale? Now hit graph. Now that's cool, but look, here's all that information for you. So everybody, now you have to hit trace. And then look, you can scroll over and see all the values. There's your minimum. There's quartile 1, or your median, or quartile 2, quartile 3, and max. So if I said find the inner quartile range, you would say, okay, I need to do 19 minus 12. Do you see? So everybody, now we're going to learn one last word. It's percentile. This one always confuses people, but it shouldn't. It actually makes complete sense. So a percentile is basically helping rank yourself. I'm not going to read this because it just confuses people. I'm going to just explain it. So, for example, if you are in the 90th percentile of your GPA or lower than you. So only 10% of your class is above your GPA. So isn't that, you're pretty dang up there, aren't you? Does everybody see how it works? So if I said to you, on the test that we just took, you scored in the 42nd percentile. What does that mean? 42% of students scored below him. Does everybody hear that? So you're down there, a little lower. But at least there's 42% of people still below you. But do you see what I'm saying? Okay, so it says right here, percentile is a number from 0 to 100% that you can associate with the value X from a data set. It shows the percent of the data that are less than or equal to that. So let's look at these scores and make sense of it. Now this is actually used, you'll see, this is actually literally what you, if any of you are planning on applying to law school or any Ivy League school. Any Ivy League school you will take, you will have to take the SAT. On the SAT, they will say to you, you scored within the 90th percentile. And so, yeah, you're going to get accepted to the Ivy League school. If you scored in the 30th percentile, you're low. Like, only 30% of people are scoring below you. So you're not going to get accepted. If pre-law, like, I know for a fact, I bet we can look it up. Like, Harvard, for sure, has a cutoff. You have to score on the LSTAT exam within the 80th percentile to get into our law school, period. And then you also have to have all these other things. Does that make sense? Okay, so let's look at these scores. Let's say these are the scores on our last exam, everybody. Everybody look, because we did have a 100 in here. These are the scores from our last exam. So maybe one of those is your score. Let's see what percentile you fell in. So if I said to you, what score? So here are 20 students, everybody. Here's 20 students' scores. Now, here is one thing to note. You do need the scores listed from least to greatest. So isn't the lowest score a 41? Our highest score is 100. Does everybody see? So if I said to you, what score was in the 65th percentile? This is how you would do it. It has nothing to do with the scores. It has to do with the number of students. These are from least to greatest. So how many scores do we need to go in so that 65% of the data scores at that score or below it? So how you would do it is you'd say that there are 20 students. What's 65% of 20? So you would times by 0.65. That's a time sign. So what do we get? 13. So we would go in 1, 2, I'm going to erase that. In 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right there is this 82% was the 65th percentile. So what does that mean? 65%. 82 was the score that 65% or lower of the people scored at that. I didn't say that very good. 65% of students scored at or below 82%. So isn't that quite a bit? Most of the students, a lot of them, a little bit more than half, scored at 82 or below it. Does everybody see? Okay, so should that person feel bad? Not bad, not good, right? 65 still above half, but still not clear up there. Does everybody see how that works? Okay, so if I said to you, so like I said right here, I was just telling you about percentiles. I just told you. It's showing right here cutoff scores and stuff for the SAT, GRE, and LSTAT. LSTAT is the pre-law exam. So now think about why this puts it into context for us, everybody. If I told you you scored 67 out of 90, and you go home and cry yourself to sleep, and then you come back and find out you scored within the 90th percentile, should you have cried yourself to sleep? No, because 90% of the students scored below you, people. Should you feel bad? No, you did dang good. So do you see how it puts it more into context for you, a percentile? That 67 out of 90 meant nothing until you knew what percentile you fell in. Okay, so here are those same points. I mean, those same scores. If I said to you, what is the 55th percentile? So you'd say, well, there are 20 students. So then times that by 0.55. So how many scores in do I need to go? 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 79 is our 55th percentile, meaning 55% of students scored at that or below it. Which makes sense. You see how it's just over half. Everybody good? Makes sense? So 95th percentile, you would take 20 times it by 0.95 and you get 19. So there are 20, so that would be right here. The score of 98, 95% of students scored at 98 or below it. So you're up there really high. Does the percentile make sense? People get confused by it. Okay, that's the end of 8-1. So you'll have the rest of the time till lunch, 3 minutes, and then when we get back from lunch, a couple minutes, and then we got to move on to 8-2. Easy stuff though, right? Yes. We're talking about spread. It's more about spread. So standard deviation is talking about how the data is spread out. So what a standard deviation is a measure of how far the numbers in a data set deviate away from the mean. Now remember, mean means average. So I'm going to kind of put it in perspective. If we have some data set, I'm just going to draw a line here. If we have a data set with a bunch of numbers in here, we can find the average, which could fall either right. I mean, it might not fall right in the middle, but it's going to be pretty close, right? Somewhere around the middle, right? Let's say that the star is the average. Well, then we're going to talk about standard deviations in a second and what they mean. But all the rest of all of the data will fall within either 1, 2 standard deviations and so out. It'll all fall. It'll be spread out away from the means. Standard deviation wise, it'll be spread out from the mean. So we will show you how to use your calculator to find standard deviation. It's how far it deviates away from the mean. And then variance, I'll show you how to find, but we're not going to use it for anything. This is not a statistics class, but we will use standard deviation. But it does ask you to find variance, which you'll just use your calculator. Okay, so it's going to describe spread. So everybody grab your calculator. I'm going to show you how to find it. So it says, what is the mean, variance, and standard deviation? Let's just do, instead of this example up here, let's go to number 1 on 8-2. So everybody go to your calculator and hit the stat key. And then go into edit. In list 1, you need to type in those values for number 1 on 8-2. So I'm going to type them in real quick. You type yours in. Okay, I've got them all typed into list 1. Then you're going to hit the stat key again, and we're going to calculate. Now, we're only dealing with one data set, so we're going to do the one variable statistics, and that's what we will always be doing at this level of statistics. The one variable statistics. So hit enter. Now, I'm going to explain to you how they write a few things. So X bar is just a quick way of them saying the mean. So I would write this down on my notes. If I said you find X bar, you have to know that that's asking you to find the mean. And then we know that sigma is the standard deviation. And then sigma squared, you would just take your standard deviation and then square it by hand, like in your calculator, and that's your variance. So everybody, look on your calculator and tell me what that mean is of that data set for number 1 on your thing. Hey, look, X bar is 295.6. So X bar is 295.6. So do you see how nice it is? Because you don't have to do it by hand. Then from there, just skip all the stuff that we're not looking at. This says the sum. We don't care. Go down to the sigma. So our standard deviation is 47.4. So now to find the variance, we would calculate it by hand. We would do 47.4 and then we would square it. We would just type it into our calculator. It'll get rid of the one variable statistics if you do that. And I want to show you something else, so I'll just tell you. So the variance is 2,246.8. Because I squared 47.4. And then I want to show you what's cool. So now look, you don't even have have to know how to make a box and whisker plot. Because look, if you scroll down, n equals 9 means there was 9 points in the data set. There's your min, so that would be the bottom of your whisker. There's quartile 1, so the bottom of your box. For your median, so do you see how now you could just type it into your calculator for 8-1 and it will find the median for you? And then look, quartile 2, or median, sorry, and then quartile 3 would be the top of our box, and then look, our maximum is 398. That would be the top of your whisker. So if you know the one variable statistics, you can literally do everything, except for mode. So now let's put into context what standard deviation really means. So everybody look right here. So in a data list, every value will fall within some standard deviation away from the mean. For example, I'm going to draw you a little picture here. I'm going to scroll this down. If I told you that the average, the mean is 50 in a data set, and the standard deviation is 10, then one standard deviation above would be 60. One standard deviation below would be 40, correct? So if I said to you, there is a score of 44, how many standard deviations away from the mean is it? You would say 1 standard deviation. Do you see how easy that is? So then 2 standard deviations away from the mean. We're going further out away from the average. So we're getting now more spread out. That would be 70. So if I said to you, there's a score of 62, you would say, well, that's 2 standard deviations away from the mean. And then 2 standard deviations, that would be 30. You guys get the picture, right? So the further out we go, the more spread out the data, and it's less reliable. If you're the closer in, the less standard deviations, the better, because it's not so spread out. It's not, you know what I mean? It's more accurate because it's all close together. Okay, so look right here. It says, this is exactly how it works on the homework. How many standard deviations does all of the data fall? There's a lot of misconceptions with this one. So it says, given this data set, how many standard deviations does all of this fall? So we're given that the mean is 37, so I would draw myself a picture. There's our mean. Then our standard deviation is 12 minutes. So let's draw ourselves a picture. 1 standard deviation above. What's 37 plus 12? Yep, and then let's go 1 standard deviation below, so 37 minus 12. There's 1 standard deviation. Let's go 2 standard deviations out. So add 12 again. Subtract 12. 2 standard deviations. So where would we be at? And let's just start there. We could go out 3 standard. Couldn't I go out again? But I'm just going to stop and see where we're at. So let's look here. 27 minutes falls within how many standard deviations? 1. 30 minutes. 1 standard deviation. 47. Right here? Still 1. Just 1 above, but still 1 standard deviation. 35 is here. 30 is here. Do you see how this is all really good data so far? It's all close to the average. 40 would be here. Still 1 standard deviation is great. 35 here. We're still within 1 standard deviation. 22. Oh, isn't that within 2 standard deviations? And then 65. That's even further. Wouldn't that be out here? So it's actually, the 65 was at the 3 standard deviation. So it says, how many standard deviations does all of the data fall? Our answer would be 3. It took 3 standard deviations to trap all the data. Do you see? You don't add them up. People were like doing weird things last hour. So our answer is it took 3 standard deviations. Now here's you should write this down. Here is what technically, like mathematically, how you know for sure something is an outlier. If it falls outside of 2 standard deviations, it's an outlier officially. So if it's out within 2 standard deviations, it's not an outlier. After that, if it's within 3 standard deviations, 4 standard deviations, it's an outlier. Did you write that down? So did this one? So look, because it took us 3 standard deviations, we know there was at least 1 outlier. Because it took 3, you see? And which one was it? Oh, the outlier is officially 65. So it's kind of interesting because everybody, I want you to look on your homework. Like, look at number 7. 72. Doesn't that look pretty close to all those points? If you look at the points on there, does it seem that outrageous? No, but if you were to put this in, that's actually by definition an outlier because it falls it's within 3 standard deviations out. Does that make sense? So really, a statistician wouldn't just look at something and say, yeah, that's an outlier or not. They would do something like this to find out which point is officially an outlier, and then they might throw that out. They might not, but just to see where we're looking. So everybody listen, this is important to understand. The less number of standard deviations, the closer the spread, the less spread out it is, and that's more reliable data. Okay. Do you need another example or no? So just keep in mind, though, they won't always give you the standard deviation and the mean. So if I said to you, given this, I won't go over it if you'll just make sure you tell me you can know how to do it. Given these set of points, if I said to you, how many standard deviations does all of the data fall? Do you see how it doesn't give you the mean or standard deviation? You'd have to do the list 1, you would type it in, you do the 1 variable statistics, you'd find X bar, which is your mean, you'd find sigma, your standard deviation, and then you could create a chart like I just created and go through it. Does that make sense? Okay, that is the end of the lesson. So the more standard deviations, the more spread out. 3 standard deviations or more would be an outlier. Okay, cool. So finish the worksheet. 8-2. I would do some standard deviation ones.